In 9.2, we're going to see what happens when we take a square root of something that's not a perfect square. But this is where we really need to know our multiplication tables as well as the perfect squares. So remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So we're going to use a property. If we have a times square root of a times b, we can rewrite that as square root of a times square root of b. And what we're going to do is, when we have a number that's not a perfect square, we're going to see which one of these numbers will divide evenly into it to make it so that we have this. So let's say we have square root of 40. And what we're going to do is go backwards from 40 here. So 36 will not go into 40, 25 won't, 16 won't, 9 won't, but 4 will. 4 will go into 40 10 times. So we can rewrite this as square root of 4 times 10, or square root of 4 times square root of 10. We can take the square root of 4, which is 2, and we keep square root of 10. So our answer here would be 2 square root of 10. In myopenmath, you might have to say 2 times square root of 10, and it's SQRT, and then you put the number in parentheses here. Or if you use the math quill, which is the red arrow in the yellow box next to the answer box, there is the little square root radical symbol. Okay, so let's say though that we have square root of 18. The perfect square that will go into 18 is 9, and it goes 2 times. So we can say square root of 9 times square root of 2, and we can take the square root of 9, which is 3, and we still have square root of 2. Okay, so let's do a bigger number. Say we have square root of 500. 100 will go into 500 5 times, so we can say square root of 100 times square root of 5. We can take the square root of 100, which is 10, and we're left with square root of 5. But let's say that we didn't use the 100. Let's say that we realize that 25 will go in. So this can also equal square root of 25 times 20. We can take the square root of 25 times square root of 20. Square root of 25 is 5. We still have square root of 20, but a 4 will go into 20, and it'll go 5 times. So this can be written as 5 square root of 4 times square root of 5. We keep the 5, and it's times square root of 4, which is 2, square root of 5. 5 times 2 is 10, square root of 5, which we got here in one step. So this is just to show that you can sometimes use a smaller square root, but you have to check to make sure that no other perfect square will go into that number. So another one that starts like this, say we have 7 times square root of 5. Now what we did on that last one is we had the 5 on the outside of the square root when we did the square root of 20, and here we already have the 7. This really means 7 times square root of 75. So square root of 75, a 25 will go into 75 3 times, so we can rewrite this as 7 times square root of 25 times square root of 3, which equals 7 times square root of 25 is 5 times square root of 3, which equals 35 square root of 3. So that's what we're going to do when we have a number in front of the radical, which is the square root sign. Okay, also remember that square root of a divided by b is the same as square root of a over square root of b. And we've done some of these before when we had a square root of a fraction. And that's all we're doing here. So say we have square root of 16 over 81. That's the same as saying square root of 16 over square root of 81, which equals 4 over 9. If we have square root of 2 over 25, we can say square root of 2 over square root of 25. We can't do anything with the square root of 2, so we just keep it, square root of 2, but the square root of 25 is 5. Say we have square root of 45 over 49. We can rewrite this as square root of 45 over square root of 49. Square root of 45 isn't a perfect square, but 9 will go into 45 5 times, so we can rewrite this as square root of 9 times square root of 5, and square root of 49 is 7. Now we can take the square root of 9, which is 3, we keep the square root of 5, and we have a 7 in the denominator. Okay, so now let's look at what we have when we have an odd exponent. Because remember, when we had an even exponent, we just divided it by 2. But say we have something like square root of x to the 11. If you remember, when we had a times m times a times n, that equaled a times n plus n. We're going to use that, but backwards. So here, we're going to change this into, we're going to subtract 1 from the 11. And we're always going to subtract 1 from an odd exponent. So when we subtract 1, we're going to get x to the 10, and that's times x to the 1. Because now here, x to the 10 times x to the 1 is the same as saying x to the 10 plus 1, which is x to the 11. So now we can take the square root of x to the 10 by dividing the 10 by 2, and we get x to the 5 times square root of x. So now whenever we have a square root of a variable with an exponent that is odd, we're always going to have square root of just that variable as part of our answer. So let's do one, say 18x to the 4. I'm going to break this one up because a 9 will go into 18, so it's going to be 9 times 2 times x to the 4. We can take the square root of 9, which is 3. The square root of x to the 4 is x squared, and we're left with square root of 2. But let's say that we have square root of 288 x to the 23. The biggest perfect square that will go into 288 is 144, and it will go 2 times. So we're going to say 144 times 2. We're going to subtract 1 from 23 to get x to the 22, and we're always going to have just x to the 1. Now, we can take the square root of 144, which is 12. We can take the square root of x to the 22 by dividing 22 by 2 and get x to the 11. And under the radical, we're left with a 2 times x. So this will be our answer for this one. Now let's say that we have some that are fractions. Let's say we have 27, square root of 27 over x to the 8. This one I am going to break up into square root of 27 over square root of x to the 8. Square root of 27, that's not a perfect square, but a 9 will go into 27 3 times. So I'm going to rewrite this as square root of 9 times square root of 3 over square root of x to the 8. I can take the square root of 9, which is 3. I keep the square root of 3, square root of x to the 8, divide the 8 by 2, and we get x to the 4 in the bottom. Then let's say that we have square root of 7 x to the 7 over 25. So I'm going to break this up to be square root of 7 times square root of x to the 7 over square root of 25. I can't do anything with the square root of 7, but the square root of x to the 7 I can break up. So I now have square root of 7 times square root of x to the 6 times square root of x all over square root of 25. And I'm breaking this up more than you really need to just to show a way to manipulate the numbers. So I can't do anything with square root of 7. I can't do anything with square root of x, but those two are going to be under one square root sign when I finish. The square root of x to the 6, divide the 6 by 2 and get x to the 3, and we keep square root of 7x, and the square root of 25 is 5. Okay, A couple more here. Let's say we have square root of 18 over 98. Okay, what I'm going to do is break these up. A 9 will go into 18 2 times, and 49 will go into 98 2 times. So I'm going to break this to be square root of 9 times 2 over square root of 49 times 2. Now when I take the square root of 9, I get 3 square root of 2 over square root of 49 is 7, and I still have square root of 2. And now because these are multiplications here, I can simplify. Square root of 2 divided by square root of 2 is just 1, so my answer here will be 3 over 7. And that is pretty much it for 9.2. On all of these, you're going to be able to have no square root sign in the denominator. You'll always be able to take the square root of what's there. In the next sections, we'll see what happens when we can't do that.